My name is Hennessy and I'm a PhD student affiliated with University College Cork in Ireland and Okinawa Institute of Science and Technology here in Japan. And I study tapered optical nanofibers in the Quantum Systems unit here in OIST, and I want to tell you a bit about why I think they're so interesting and the cool things you can do with them. So many of you will have heard of transistors. They're the basic building blocks of modern electronics, and they're like the bits inside your computer that does the computing. And something called Moore's Law tells us that over the past 40 years or so, the number of these transistors you can fit on a chip has approximately doubled every 2 years, and this is what's allowed computers to get smaller and smaller and smaller, and now we're hitting the absolute limit of that technology, in that technology is being developed that will allow us to use single atoms as transistors. It'll allow us to do computing, and not only that, but a new type of computing called quantum computing with single atoms. Now, if we're going to want to do computing with single atoms, we're going to need to develop a new toolbox of devices that will allow us to manipulate and control single atoms, because as you might imagine, that's a very difficult thing to do. And I work with tapered optical nanofibers. So you make a tapered optical nanofiber by taking a regular telecommunications fiber, holding it over a hot flame and stretching it. And this allows experimentalists to make a new tool, which is a regular telecommunications fiber at either end, but in the centre has this really tiny tapered piece of fiber that you can do all kinds of interesting things with. Now, my pictures aren't drawn to scale, so you have to imagine that this tapered part in the centre is way, way, way smaller than the two ends. In fact, the fibres that I consider in my work are something like 260 times smaller than a human hair, so we're really talking quantum world tiny. So you might imagine that when light is travelling in one of these fibres, when it arrives at the tapered part, even the light is kind of too big to fit in the fibre anymore, so you get much of the power of the light field travelling outside the fibre surface. And that's really cool, because if atoms are sitting close to the fibre surface, they will feel a force due to that light field being present. If you can control the light that an atom feels in the quantum world, you can control where that atom wants to be. So by very specifically choosing the properties of the light you're shining into your fibre from either end, you can create places around the fibre where the atoms prefer to be. Now that's really cool, because using our what you might call a quantum funnel, our fibre, we can deliver light in a very specific way to atoms, and we can make them sit in, say, a spirally pattern or in an array around the fibre surface. And so using our fibres, you can make single atoms sit exactly where you want them to sit, and if you can do that, you can start to play all kinds of interesting games and do all kinds of interesting physics in the quantum world. And I'd tell you more about that if I had more time, and I'd tell you more about the interesting physics we learn along the way, but I guess I'm out of time, so thank you very much.